Dependency injection is a really powerful concept you should start adding to your project. In front of me here, I have an example application where I have implemented some code, currently not using any dependency injection concept. And I want to walk you through the code and highlight some of the problems that I currently have with this setup. Then I want to refactor the code with you to see how we can solve these problems using dependency injection. So right now I have a whole new application. This is basically like an Express application, a JavaScript framework for creating APIs. I am mounting a route, which is this recipe controller. I like to split my code up into 3 different layers. The first being a controller layer, where we handle all of the requests and HTTP related stuff. Then that sends whatever the request contains to a service layer. This is where we want to handle all of our business logic. And finally, that service layer forwards things to a repository layer where we do stuff talking to the database. So fetching things from the database or saving things to the database. So if we take a look at the controller, this simply implements 3 endpoints, one for getting all the recipes, one for getting a single recipe. And as you can see here, it handles getting the ID from the param. We also have an endpoint for creating a recipe, and this gets the JSON body before sending it to the service. Then if we jump over to our service layer, we have functions that actually performs our business logic. Now in this application, there isn't really much business logic, but we have some here where we get the recipe by ID, we check if it exists or not. If it doesn't, we throw an error, otherwise we just return the recipe. And because we have this layer for service where we implement our business logic, we typically want to test this. And one way of testing this is using unit test. Now we're going to see with this setup that it's a little bit difficult because, as you can see, all the functions call this recipe repo, which is the final and third layer that actually talks to the database. And we can see I'm using Drizzle in this example to connect and query the database. One of the problems with this approach is that, as I said, we want to unit test our business logic, but it's kind of hard because it is tightly coupled with our recipe repo, and we don't really have any control over this. And when we want to unit test our business logic, we just want to unit test our service layer without thinking about repository layer. And right now, with this current setup, we have to actually run the whole application. We have to run our database. We have to connect to the database, all of this stuff in order to run the test. So I have a simple test setup that checks if the recipe service actually returns all the recipes as we expect. And if we run this test, we will see that it fails because we're expecting to get 1, but we're getting 0. And this is because we're connected to a real database where we don't really have control over what recipes are in it. This can change over time because the data is persistent. And this is not something that we want when we test. We want to have a consistent result. There are multiple ways of solving this. You can use like an in-memory database to spin up a fresh database every time we run the test and then destroy it when the tests are over. Another way is we can use dependency injection. And the way we use dependency injection is instead of in our service layer just importing the recipe repo and using it throughout the file, we can instead, as the concept explains, dependency injection, we can inject whatever this service layer is dependent on. In this case, will be the recipe repo. And then we will use the injection version instead of the imported version. So in this case, in this function, we could actually just provide the repo as a parameter. I'm just going to type as any for now. We're going to fix that later. And then inside the function, instead of calling this imported repo, we can just call the repo passing as param. And when we go to the test, this will enable us to, instead of not having control over what repo we are using at all, we can create a mock. Right now, we're just going to create an empty object. And then we can pass the mock in as the repo, and then we can set a specific state for that mock. And then we can check that when this mock is in a specific state, that the service actually does what it's supposed to do when the mock is in that state. Now, right now it's going to return false because the mock is just an empty object. It doesn't actually have the function for getting the recipes, but we're going to fix that later. Now, this is one way of doing it, but it's a really naive way of doing it because right now, everywhere we want to use this get recipes function, we have to actually have a reference to the repository and we have to pass it in as a parameter. Furthermore, all of the functions in this file all are dependent on the recipe repo. So doing it this way, we will have to pass the repo into all of these functions. Now there is a much simpler way of doing this, and that is to use the classes that JavaScript have. I'm gonna refactor this code into using classes, and I'm going to walk you through how that will look. Okay, so now I have refactored the code to use classes and also dependency injection. So if you go to the right, this is now the new recipe repo. This is now its own class, which has the same functions for getting all the recipes, getting a recipe by ID, and saving a recipe. But in the recipe service, we have some more stuff. We have this private field, which is of type recipe repo. This is the type of this class that we have defined on the right. Then we have this constructor, which actually populates this field with an actual repository. And then in the function, instead of importing the recipe repo directly in the file and then just using it, we're using this repo field in this class. And this way, now if we go to the controller, there will actually be an error because we don't have this recipe service available to us. All we have to do is we can create a new constant, and we can create that using this class. So we can create it with a new recipe service. Now this expects a repo. So what we can do is we can create a repo, call it from the recipe repo class that we created, and then we can pass this into here. And then instead of using this, let's just call this a recipes service. And then we can use this recipe service that we create up here instead of using the imported that we had earlier. Now you might be asking yourself, why do we want to do this? This is just more boilerplate in our controller. We now have to initialize our repository and our services, and we have to create these like class wrappers around our functions. Why do we need all this stuff? And the reason is that now we can actually, in our test and in other scenarios, we have more control over the service. We can add whatever repository we want into this recipe service. Now there actually is one more step that we need to do to make this like the full experience that we want. So I'm going to do that real quickly, and then I'm going to walk you through the new code for that. So the additional thing that we have to do in order to make this like the best experience that we can is to create this interface. This is an interface for the repository, and this just tells us what the repository, like what function it has, and the signatures of them, so what they should return, what they expect as parameters, and all that stuff. And then in our recipe repo class that we implemented earlier, we want to say that this implements this interface. So we're basically saying that, okay, this recipe repo has all the functions that the interface says that it should have. Then when we go to the service, we can say instead of expecting it to be a repository repo, we can expect it to be a type of the interface that we define. We don't really care how the class implements the function. We just want it to implement the methods that we're going to use. And when we go to the controller, we can see that this still works because this recipe repo implements that interface. So when we pass it into the service, it works. And why we want to do this is that now we can create multiple different versions of this interface. For example, this version that we have now uses Drizzle to connect to our actual database. What we can do is we can create a mock version of it, for example. And then I have some code off screen. I'm just going to copy that. So here we have now a mock version of the repository. It implements the exact same method with the exact same parameters and the exact same return type, but it does so with this internal array of recipes instead of actually calling the database. And now if we go over to our test, we can actually use this. So we can create a mock repo, which is going to be using this recipe mock that we just created. And we can create now a recipe service, which is going to be that same recipe service that we created in the controller. But instead of passing the actual repo connecting to the actual database, we can pass in the mock repo instead, just like this. And then if I give this the correct name, we can see that we don't get any errors. And if I actually now run the test, we can see that it passes because our mock repo has one recipe in it. And now we have full control over the recipe. So we can, in this test, we can have this recipe mock, and in another test, we can create another mock with another state, and we can check that the service handled that state correctly. And this is all working because we are now injecting the repo as a parameter to this class instead of just importing it and using it directly. This means that we now have more control over our service layer, and it's more modular and easier to work with. So with this, I hope that I have been able to highlight the importance of dependency injection and why you might want to use it in your own application. The key takeaway from this is that instead of just importing the things directly, you want to inject them either through a parameter or maybe wrap your functions into a class. It is also important that it might be useful to create an interface so that you can create multiple versions implementing the same interface but in different ways. For example, now I have a mock and we also have the repo which uses the actual database. Creating the interface enables you to abstract away like the implementation details and only care about what the class should actually provide, like what function it should provide and how you should use the functions. So with that, I hope it all makes sense and I hope you understand what dependency injection is and why you might want to use it. If you have any questions, please leave a comment, and if you like the video, please give it a thumbs up, and I will see you in the next one.